From the Gert Boyle studio at OPB, this is Think Out Loud. I'm Jeff Norcross. The winter we just had here in the Northwest was one of the warmest ever, and that means a lot of cold, mountainous places that normally get a lot of snow got a lot of rain instead. It means the snow structure is different in some parts of the region, and that changes the avalanche risk. Clinton Alden is the lead author of a new paper about this. He's a PhD student at the University of Washington, and he joins us now. Clinton Alden, welcome to Think Out Loud.
Thanks for having me.
So I gather from your paper that this is not a snow problem or a rain problem per se. It's kind of how the snow and the rain sit together. Can you explain that?
Sure. Yeah. So our snowpack and snowpack more generally is composed of various different layers. And we can think of our snowpack kind of as a timeline of the weather history over the course of the winter. So as we have different types of weather events, if we have some big snowstorms and then we have some rain that falls on that snow and refreezes, we can get these ice layers built in within the snowpack, and then we might have more snow that falls on top of it. And that layered structure persists throughout the whole winter. And you can actually dig through the snow and see that even weeks to months later after those layers form.
And why is that ice layer in the middle of that snow sandwich a problem?
Yeah, so these melt freeze crusts, as we call them in this paper, can change the type of avalanches we see and sometimes can turn into pretty large destructive avalanches that are hard to mitigate for highway operations and ski resorts called wet slab avalanches. And that's kind of one of the findings we found in this paper was investigating the changes in those crusts.
How is a wet slab avalanche more destructive than one that doesn't have that kind of snow composition?
Sure, wet slab avalanches can be comprised of really dense, heavy snow. And we have these crusts, and you have water percolating through the snowpack that pools on these crusts, be it from a further rain event or from a warm temperatures, and you're having snow melt. That can lead to very large avalanches, both in like vertical depth and very wide avalanches. And then that heavy, dense snow can be very destructive.
Yeah. You point out that this is a problem in the colder parts of the Pacific Northwest. Can you be specific?
Sure. So we were looking at places that are currently quite a bit colder. So one instance of this is like the North Cascades, the east side of the North Cascades.
The
And
east
we
side, that's important, not the west side where
Correct.
which faces the ocean and is more mild.
Correct, exactly. And then we also expanded looking at, I guess you could call it the broader Pacific Northwest, including places in Montana and Idaho. And that's really where we saw the increase in those melt freeze crusts was in those colder places in Idaho and Montana.
Do avalanches typically not happen in those areas?
So it's really not so much about how many avalanches we have. I think this work really might show the changes in the types of avalanches we have. And depending on those types of avalanches that we see, that can change how, highway operations, Department of Transportation's approach their avalanche mitigation work.
Okay, so it's not so much a more avalanche problem, it's more like a different avalanche problem, and those different avalanches have more downstream effects.
Correct, exactly.
Can you point to a specific area that is experiencing different avalanches right now?
Sure, it's actually very relevant just this week. So there were several, this is outside the Northwest, and outside of our study, but another cold location is the Wasatch Mountains of Utah, where they had several rain events at high elevations that historically have not really seen any rain in the wintertime. And then those same rain events created these melt freeze crusts that are then months later. I mean, these formed back in December, and now months later are leading to large destructive avalanches that have been observed this week. So that's already kind of an example of a cold interior place that historically has not seen a lot of rain on snow, but is starting to see that more as
And
the
when you
climate.
and when you say that destructive avalanches have happened there, what does that mean? What had actually happened?
Yeah, just large destructive avalanches, these wet slab avalanches. And just looking at the ski resorts actually in Utah, they've closed a lot of the terrain because of these types of avalanches, because it's difficult to mitigate effectively with explosives. And that's kind of where that different type of avalanche matters, because with the more typical avalanches you see with just fresh snowfall, those are a lot easier to mitigate with explosives for ski areas and highways. But these wet slab avalanches filling on these melt freeze crusts that it's kind of just a sit and wait type thing. You can't mitigate as effectively.
Yeah. If you're just tuning in, we're talking about climate change and avalanches in the Northwest. Clinton Alden is a PhD student at the University of Washington. He co authored a paper about the changing avalanche picture in parts of the Northwest. How much do you worry about avalanches when you're skiing or snowshoeing or playing in the snowy mountains? We'd love for you to comment on our Facebook page. You can also leave us a voicemail. I've got the phone number here, 503-293-1983. Clinton, how long have you been looking at this data?
So I've been looking at, are you interested in what period of record we were
Yeah,
investigating?
yeah. How long have you been measuring this?
Yeah, so we were using SNOTEL sites, that's snow telemetry sites run by the U.S. Department of Agriculture. And so we were able to look at a whole period of record ranging back about 25 years and use that to model a snowpack for each of these historic years, and then use that to kind of project what we might see in the future.
Yeah. Was it surprising?
I think the surprising part was that the answer to our question of how will the snowpack structure change with warming temperatures is kind of it diverged into two paths. We were maybe more thinking at the beginning of this picture of more rain equals more crusts, but we actually found kind of a different pattern in warmer locations, which is the west side of the Oregon and Washington Cascades, where we just don't get as many freezing temperatures with warming temperatures. And so we actually see that our snowpack remains, if you've ever skied at a ski resort on warm days, that like mushy mashed potatoes type snow that doesn't refreeze for several weeks. So we actually saw less melt freeze crusts in the warmer locations moving forward.
Yeah, you mentioned ski resorts a couple of times now, and even some of them closing. I I can't imagine they would feel good about being in a higher risk avalanche zone. I'm wondering what all of this might mean for the industry.
Certainly. Yeah, I think the biggest issue with the for the ski resorts this year has just been a lack of snow, more so than different types of avalanches. But of course, when we think about warming temperatures, a big key in many previous research studies as well is that our length of snow season across the western United States is shrinking as the temperatures warm.
What other effects can you point to, like maybe wildfire risk or wildlife habitat? What else? What other downstream effects might you be able to point to because of the research that you've uncovered?
Sure. Yeah, we also collaborated with some wildlife biologists at the University of Washington, and we found that based on some previous work they've done that the changes to this melt freeze crust actually has pretty strong impacts to wildlife biology. So there are many types of animals called ungulates, which are skinny-legged mammals like deer and elk that rely on being able to dig through the snow to get to grass to forage in the wintertime. And when you get these melt freeze crusts, that kind of locks up their forage and can lead to increased mortality for some of these animals when they're not able to access their food.
Hmm. What questions do you still have about how the changing climate is affecting avalanches out here?
Sure. I think we really were investigating, the types of avalanches, and I'd be more interested to see about how many avalanches, and that's really hard, and I don't know that we maybe have the numerical models, the weather and snow models to do that this time, but that would be another question I'd have for sure.
So there's more research to be done?
Of course. Always.
Yeah. How, I guess I should ask, how has so far your research been funded?
So this work was funded by the NASA Interdisciplinary Research in Earth Sciences program.
And I have to ask, anybody who relies on federal funding for research these days has to wonder about the reliability of that. What can you say about the sustainability of this work right now?
Certainly, I know that in our research group, there's been some challenges to securing funding. I think a common theme that I've heard among researchers across different institutions is that people are just applying for grants and they're just not hearing back because I think a lot of these federal agencies have a lot of uncertainty with their budgets. And so we're seeing a lot of federal grants that are just pending for months to over a year now, which is leading to a lot of uncertainty.
Yeah. What about you? How are you thinking about the future of the snowpack out here and your own work on climate change?
Sure. Yeah. I think that there's still a lot of interesting work being done, and it gives me hope to see the passion that people bring to the table. And hopefully, as more funding comes through, we can continue this work.
Why are you interested in this? Why do you love this work?
Sure. I grew up in San Diego, California, and although that's not a very snowy place, as a hydrologist, San Diego, like the vast majority of the Western United States, relies heavily on snow for our water, for our drinking water, for our agriculture, and our snowpack is also so sensitive to climate change. So it's kind of the intersection of water resources, avalanche risk, and as a skier and climate change that really motivates me to keep doing this work.
Yeah, and I'm wondering how what you've uncovered so far over the last 25 years, what it says about this broader question about how the climate is changing and what it means for our lives in snowy places or not snowy places.
Sure. Yeah, I think part of the reason why we were so interested in the warming temperatures component is because climate change, there's a lot of uncertainty as to what it might mean for our precipitation patterns, for our clouds, for other downstream weather impacts. However, one of the things that we do know with high confidence from future or further past climate studies is that we are going to see warming temperatures somewhere in the 2 to 4 degrees Celsius range by the middle of the century in the Northwest compared to pre-2000 levels.
Does that mean the avalanche risk is going to change even more broadly, not just in the Northwest?
Yes. Yeah. As temperatures change, our snowpack changes because snow is just so sensitive to slight changes in temperature. We'll likely see that snowpack structure change more broadly.
Okay. What's the next phase of this research? What are you going to look at next?
I think the next interesting phase to dive into would be to look at the different types of snow crystals and how they change with warming temperatures. I think a lot of people think of snow as these nice, beautiful six-sided snowflakes, but actually when they are in the snowpack, they're metamorphosizing and changing into different shapes. And those different shapes impact their uh, propensity and their potential to avalanche. And so we could do future work using more complex snow models to investigate how those snow grains are going to change with warming temperatures.
Okay. And just because I'm curious, how far away from your PhD are you?
I think I got about 2 years left. That's the
Okay.
goal.
Well, we'll have to have you back on when you're Dr. Clinton Alden. How about that?
Sounds wonderful.
Thank you so much.
All right. Thanks for your time.
Clinton Alden is a PhD student at the University of Washington. He's the lead author of a new paper about avalanche risk here in the Pacific Northwest.